All right, y'all. So 7.4 deals with quadratic equations. Now, before we get into the quadratic equation, they introduce new terminology to you. So, a zero. Y'all, when they say find a zero of a function, they're talking about the solutions. So, zeros, those are solutions to quadratic equations. That are found by setting the equation equal to zero. And I guess since you're setting the equation to zero, that's why they call the solutions zeros, okay? Also, y'all, this thing about them. A zero is where the graph of the quadratic equation crosses over the x-axis. So y'all, that's why I was telling y'all you could graph yesterday when you was trying to factor and solve those equations. And I was showing y'all where it crossed over the x-axis was the solutions. And that's because when you cross the x-axis, the y value on the x-axis is zero. So it all has to deal with these zeros, okay? All righty. So I'm going to list the ways to solve a quadratic equation. All right, so the first way to solve a quadratic equation is solving by factoring. Okay, that's what we did yesterday. We factored it. Once we had the two factors, we set each of them equal to zero. All right, another way, solve by square roots. So if you remember in some of the support, we solved those equations by square roots. When I got the x squared by itself and a number on the other side, and then we did the square roots. And then that's when I introduced you to the plus or minus on those. But you can only do the square roots if it's missing the x term. So missing the x term. So that means you'll have the x squared and a number, but you won't have a x term on it, okay? The third way, which we'll deal with today, is solve by quadratic formula. And y'all, we can use the quadratic formula. It'll solve any quadratic equations. Solves any quadratic equation. So it'll work every single time, that quadratic formula will, okay? It'll give me real answers. It'll give me imaginary answers. Now, the fourth way was what I showed you with the graphing. You can solve by graphing. But y'all, there's a stipulation on factoring and graphing. Factoring You only get real solutions. Which means you won't get the imaginary answers when you're factoring. And then graphing, the same thing. You're only going to get real solutions. So graphing and factoring will give you all the real solutions, but they won't give you imaginary solutions. And y'all, sometimes these will have those imaginary solutions, okay? So let's go through some of the examples in 7.4. Okay, so this will be like number one. It says find the zeros of the following. So zeros are the answers. And y'all, the first one they made, we can factor this one. F of C equals C squared plus 6C plus 8. So the first one, we can actually solve this one by factoring. Okay, because I can find factors of 8 that'll add to get me a 6 in the middle. So since I know this will factor, I'm going to set it equal to 0. And then we're going to factor this trinomial. So you got a C squared, so that's going to put a C in front of both parentheses. So in the front, you'll either have an X squared, C squared, something like that. Now, remember what we said yesterday when I gave you all the steps on factoring. I said if the last number was positive, and my 8 is positive, that means that both of these factors will have the same sign as that middle number. So that means that both of these will be plus. And remember, I gave y'all the 4 different patterns these made yesterday, okay? Now, y'all, all I need now are factors of 4. So what multiplies to give me an 8? That'll add to equal 6. So write your factors of 8 down. That'll be 1 and 8 and 2 and 4. So that's the only way I can multiply to get an 8. And I need the 2 numbers that add to get 6. So of these factors, the 2 that add to get 6 are 2 and 4. Hey, also, this is factored. Now I'm going to set them equal to 0. And y'all, the first one, I'm just going to subtract 2 from each side, and I get C is a negative 2. And then the second little equation, I'm just going to subtract 4 from both sides. And I get C equals a negative 4. Y'all, what this means, if you were to graph this one, if you were to graph this over here at negative 2 and at negative 4, that's where this graph is coming across. So if you'd have graphed it, you would have got the same answers because that's where the graph would have crossed over the x-axis at, okay? So y'all, number one is just getting you back into the one way that you can solve those is by factoring. So now the rest of these are going to be problems that I cannot factor. Okay, so they're going to sort of turn it up now. And we're going to get into that quadratic formula. All right, y'all, so number 2, same thing, find the zeros. They're giving me f of x equals x squared minus 2x minus 4. Now, y'all, the reason I know I can't factor this one, because this one you would have to find factors of 4 that subtract to equal that 2 in the middle. And the only factors of 4 are 4 and 1. 4 minus 1 is 3, so that don't equal 2. And then 2 times 2 is 4, but when you subtract 2 minus 2, you get a 0, not a 2. So this one does not factor. So since this does not factor, we got to use the quadratic formula. So we must use the quadratic formula. All right, y'all, so I'm going to take this function, set it equal to 0, x squared minus 2x minus 4 equals 0. So my quadratic formula was x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. So what we're about to do is start plugging into this. So we got to figure out what a, b, and c are. Well, y'all, a, b, and c are the numbers in front of these terms here. So that's a 1x squared, so a is 1. That's a negative 2x, so b is negative 2. And then c is the negative 4. So all your numbers are coming from your quadratic equation here. Now we're going to plug them in. Now y'all listen. You got a negative here in front of the b, so bring down that negative. And then you're going to put your b in parentheses because it's a negative 2. And then you got your plus or minus square root b squared. So that's going to be negative 2 squared minus 4 times a, which is 1, and c, which is a negative 4. Y'all, all of that, 2 times a, which is 2 times 1. So y'all, the things you got to realize is that negative here, this negative is always in the formula. The 4 is always in the formula, and the 2 is always in the formula. So we plugged everything in, so now we just need to start simplifying it. Well, out front, you got a negative times a negative 2. 2 negatives make that a positive 2, plus or minus my square root. I got negative 2 squared. Well, negative 2 times negative 2 makes that a 4. And y'all, everything on this right side is getting multiplied. So you got negative 4 times 1, which is negative 4, times negative 4, which makes that a positive 16. And y'all, all of that is over 2 times 1, which is 2. All right, so the only thing I can do now is add that 4 plus 16 up under that radical. So bring down to 2, plus or minus square root. 4 plus 16 gives me 20. And y'all, all of that over 2. So y'all, now we got to simplify this square root of 20. So let me go to the side here. So y'all, here's the thing about these square roots. A square root cannot contain a factor of a number that is a perfect square. So y'all, I'm going to write my perfect squares over here for you. And just give you a little bit of a radical simplifying. So y'all, perfect squares are numbers you get when you multiply the same number times itself. So 1 times 1 is a perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Then you got 49, 64, 81, 100, 121, 144, 169. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. These are what we call perfect squares, because if you take the square root of 4, you get a 2. Square root of 9 is 3. Square root of 16 is 4. Now, when you're simplifying a radical, we don't care about the 1. Okay? So here's my question. You got a 20 down here. Are any of these factors over here a factor of 20? And y'all look at that. You got a 4 sitting right there, right? You can multiply 4 and get a 20, right? So what I need to do then, I'm going to rewrite 20 as that perfect square of 4 times 5. And y'all, 4 is the only number I could have picked that's a factor of 20. It's because here's 20, right? How can you get a 20? 1 times 20, 2 times 10, and 4 times 5. That's all the possible ways to get a 20 by multiplying. But only one of these factors is the perfect square, and that was that 4. Okay? So I couldn't use 2 and 10 because those numbers ain't perfect squares. I couldn't use 1 and 20 because 20 don't help us. I still got that 1 there, right? So now, why did I pick the 4? What's the square root of 4? So that now turns into a 2 times the square root of 5. So now under the radical, there's a 5. And the 5 does not have any of these factors over here. So since the 5 can't be broken down anymore, I would replace that square root of 20 with that 2 square root of 5. So that this gives me 2 plus or minus 2 square root of 5 all over 2. All right, so here's the last step. The last step on this is to divide all the numbers outside by the bottom number. So divide the outside numbers by the 2 on the bottom. Well, y'all, here's the 2. So dividing this 2 by 2, 2 divided by 2 makes that a 1. Then we got our plus or minus. And then 2 square root of 5 divided by the 2 leaves me 1 square root of 5. So what you got to realize is that everybody on top, all these outside numbers got to get divided by that bottom one. You cannot divide a number under a radical by a number that's outside of a radical, okay? So that's why I can't do nothing with that 5. But it's got to be all the outside numbers in order to reduce that. And then, y'all, this would be my final answer. MATLAB will let you use the plus or minus. But what this really means is that one answer is 1 plus square root of 5, And the other answer is 1 minus square root of 5. Okay. But instead of having to write them twice, MATLAB will let you use that plus or minus on it. So y'all, that's the quadratic formula. And I'm not going to lie, the biggest thing on the quadratic formula is being able to simplify the radical. So you need to take a list of these numbers because these are the perfect squares. And if you got a number with a perfect square in it, you got to break it out like I did that for, okay? All right, y'all. So let's try number 3. Now, y'all, number 3 wants me to solve it. So they're giving me x squared plus 5x minus 7 equals 0. Now, here's the thing on this one. They want me to write the answers using the radicals like I just did on that one. And they want us to do decimal approximations. So the exact solutions are going to be the radicals. The approximations, we're going to have to punch them in the calculator and see what those equal as a decimal, okay? Also, here we go. A will be 1, B will be 5, C will be a -7. So remember, this one said write exact answers and um, decimal approximations. And on the decimals, they're going out 3 decimal places. Y'all, so I got my A, B, and C. I'm going to plug them into my formula. X equals negative times B, which is 5, plus or minus square root 5 squared minus 4 times A, which is 1, C, which is -7. All of that over 2 times my A, which is 1. All right, y'all. So are you noticing this little negative out here in front? All it's doing in the long run is changing the sign of whatever your B was. Because a negative times a 5 makes that a -5 plus or minus square root. All right, y'all. So 5 times 5 is 25. Once again, everything on that right side is being multiplied. So -4 times 1 is -4. -4 times -7 makes that a positive 28. And y'all on the bottom, 2 times 1 is 2. All right, so the last step I can do right now is add 25 and 28 together. So I got my -5 plus or minus square root 25 and 28 give me 53. And y'all, all of that over a 2. So I'm going to try to see on the side if I can simplify that square root of 53. And y'all remember my perfect squares I had 4, 9, 16, 25, 36. I'm just going to go up to 49 this time because that's only a 53 sitting there. So the question is, are any of these perfect squares a factor of 53? And y'all guess what? 53 is a prime number. So this 53 does not have any of these factors. So this does not simplify. So since this square root of 53 does not simplify, this is my final answer. This is the exact answer.
I think sometimes I try to take the problem too far when
And
working in it.
yeah, and these, you just got to be careful on these radicals. Like that 20, it did have a 4 as a factor, but this 53, it has no factors that are perfect squares. And so
Right.
that don't, and at this point, you're done. And that would
Okay.
be the exact answer. Now, to get the decimal approximations, we're going to have to use our calculator. So this is like -5 plus square root of 53 over 2. And it's like a -5 minus square root of 53 over 2. But MATLAB will let you use the plus or minus instead of having to write this thing twice. Now, for the decimals, we actually got to punch this in the calculator twice. So y'all, let's go to the calculator and I'll show you how I would put that in. All right, so the first thing I would do is probably get a fraction by going the green alpha button, y equals, and enter on that ND. That'll put it on the screen like a fraction there. So on top, I had a -5, and I'll do the plus first, plus, and then second, x squared brings up that radical, and I'm going to put in my 53. Now I'm going to arrow to the bottom and put in my 2. And then if I arrow right, that looks exactly like the one using the plus on it, okay? All right, y'all, so let's enter, and we're going 3 decimal places. So the first answer would be 1.140. So I'm gonna keep that a zero because it had a 0 after it. Now to get the second answer, you're going to use a subtraction instead of adding. So I'm going to go green alpha y equals to get the fraction bar again. On top, I'm going to do -5 minus square root, which is second x squared, put in my 53, and then arrow down and put in my 2. So if you look at these, they're exactly the same other than the top one's being added and the bottom one's being subtracted. That's why we use that plus or minus for sort of like shorthand. All right, y'all, so we'll hit enter on this one and see what the second decimal is. And that would be a -6.140. But you'll notice they both have the same decimal basically. That's because they both got that radical there, okay? All right, y'all, so in MATLAB, you would just round those both out 3 decimal places, put a comma in between them, and be done with it, okay? And that way, with decimal approximations, you can get more of an idea of what these values actually are here, okay? All righty, y'all, so let's see. This one, the zeros, and this one they're giving me f of x equals, oh, what is that? 3x squared minus x plus 4. All righty, y'all, so I'm gonna set it equal to 0. get my A, B, and C. So A will be 3. B will be a -1. And C will be the +4. All right, so we're just going to plug this in real quick and see what we get. X equals negative times B, which is -1, plus or minus square root B squared, which will be -1 squared, minus 4 times A, which is 3, and B, which is 4, C, all over 2 times my A, which is 3. All right, so I put my B here and here, my A here and here, and then my C. So once again, you got two negatives. Negative times negative makes that a +1. Plus or minus square root. Well, y'all, -1 times -1 is a +1. And then remember, all this is being multiplied down here. So -4 times 3 is -12. -12 times 4 is a -48. And y'all, all of that is over 2 times 3, which is 6. All right, so our next step is to add and subtract under the radical. So I got my 1 plus or minus square root. Well, y'all, 1 minus 48 is a -47 all over my 6. So we're down to the radical now. So let's go to the side. And let's simplify that square root of -47. So we had a 4 up here. 4 is not a factor of 47. 47 won't divide by 9. It won't divide by the 16. It ain't dividing by 25. So the number does not simplify. But y'all remember, I at least need to bring out that negative. If it's negative under your radical, you got to make that into a square root of -1 times square root of 47. So do y'all remember what I said the square root of -1 equals? So y'all chat, what did we say yesterday that the square root of -1 equals? Oh, y'all done slept since yesterday. All right, y'all remember up here we said anytime we get square root of -1, that equals the I. And it just replaces that square root of -1 so that I get an I square root of 47. So if it's negative under that radical, you're basically bringing it out as an I, which stands for imaginary. So y'all, we're going to replace this square root of -47 with the I square root of 47. All over 6. Now, y'all, here's the thing about this answer. This is an imaginary answer because of the I. So anytime we get answers that involves I, MathLab wants us to split this apart, and we need to put this into A plus BI form. We got to split it apart into two different fractions when they want it like this. Anytime you got imaginary answers, you need to break the imaginary part off from the real part. So doing that, remember everything on top gets divided by 6. So you get a 1/6 plus or minus. So y'all, that's the first fraction, the 1/6. And then this becomes the second fraction, which is a I square root of 47/6. It'll take it like this, or you can do 1/6 plus or minus square root of 47/6, and then do your I. It'll take it each way as long as you don't put the I under the radical, okay? That's why usually if I got a radical left, I usually just throw the I out front. Then you won't get it mistaken for being under there, okay? But y'all notice this. Quadratic formula gave me this answer. You couldn't have got that answer by factoring. Quadratic formula gave me this imaginary answer. Well, you can't get imaginary answers by factoring. So if you notice, those aren't bad. The quadratic formula will work every single time, okay? All right, y'all. So what I think I'm going to do next, before we do the 4/8, there's a 4/8 support. And y'all, this thing was just 4 problems here, getting you ready for 4.8, okay? All right, y'all. So my first one is A minus 3t squared. So this was just one to get you practicing on your foiling. So to solve that, I would do A minus 3t times A minus 3t. All right, so on this one, you're going to FOIL. The A times the A gives me an A squared. The A times the negative 3t gives me a negative 3AT. I'm just keeping mine in alphabetical order. Now you multiply this negative 3t times A, you get a negative 3AT. And y'all finally, negative 3t times negative 3t is a positive 9t squared. So remember, when you do an A times an A, you're adding those two exponents. And if you don't see an exponent, it's a 1. So 1 plus 1 gave me 2. Same thing on the t. They don't have an exponent, so that'd be a 1. And 1 plus 1 gave me 2. So when I'm multiplying the variables, I'm basically adding their exponents. All right, y'all, you got like terms in the middle. So bring down the A squared. Negative 3 and negative 3 give you negative 6AT. And then at the end is my plus 9t squared. So y'all just getting you more practice foiling, okay? So y'all, let's play with this one together. X to the 5th plus 8 squared. So the first thing, we're going to have to write this twice. Now, the biggest mistake I see from these problems is people will distribute the exponent inside, but if you do that, you're going to miss it every time. When you got something being added or something being subtracted like this, where they got 2 terms and they got exponents, you got to write them twice and FOIL. So y'all, let's see. X5 times X5 is an X what? What exponent would I put on that? if you're multiplying an x times the fifth times the x times the fifth. All right, y'all. So remember, when I multiply variables times themselves, I'm going to add those exponents. So 5 plus 5 gives me 10. All right, y'all. The x to the fifth times the 8 gives me 8x to the fifth. This 8 times x to the fifth gives me another 8x to the fifth. And y'all, finally, this 8 times that 8 gives me 64. Y'all, all you're doing on these is you take this x squared times both of those, and then you take the 8 times both of those, okay? Y'all, once again, I got like terms. So bring down your x to the 10. 8 plus 8 gives me a positive 16x to the fifth, and then plus my 64. Now, another mistake I see on these, when people add the like terms, they'll put 16x to the 10th here. Just remember, when you add stuff, you cannot change the variables. Cannot change stuff by adding. So 8 plus 8 gave you 16, x to the fifth. Okay? So just remember, cannot change exponents when adding or subtracting. All right, well, then they gave me some to solve. So they want me to solve c squared plus 4c equals 0. So I'm going to solve this one by factoring out the GCF. Factoring out the greatest common factor. You got a c squared and a 4c. Both of those have a c in them, right? So since c squared and 4c both have a c, we're going to factor out the c and then put what's left in parentheses. Well, c squared, if I take away a c, leaves me a c plus 4c divided by the c leaves me a 4. So if you got the same variable in both of your terms, factor it out, and then set both of these equal to 0. So I'm going to set my first factor, which is the c equal to 0, and then I'm going to set c plus 4 equal to 0. So y'all, at that point, I just set each factor equal to 0, okay? All right, y'all, well, this one's done. C equals 0. Can't do nothing to that. But on the c plus 4, we're going to subtract 4 on this one. And I get c equals a negative 4. So I still got two answers like I needed. I got 0 and negative 4. So notice this one you had your x squared term and the x term. This one was missing the number. So anytime your trinomial is missing the number at the end, you're going to solve by factoring out the GCF. Now look at the difference on this one. This one has a squared equals 25. So this one has the a squared term and a number. So remember on those, I said we could solve by square roots. And this one has the a squared over here by itself already. So y'all, that's my first move. I'm going to take a square root of both sides. Square root of a squared. Now remember, since I'm taking the square root of a number, I'm going to use my plus or minus square root of 25. So when you're solving an equation, you got to use the plus or minus because you got to get two answers, okay? So y'all, this square root cancels with that exponent, leaving my a. That's going to equal a plus or minus. And y'all, guess what? Square root of 25 is 5. So my two answers would be a equals -5, comma, +5. Oh, y'all, this one I had what? C equaled 0, comma, -4. So these two were equations. You had to solve them and get two answers for both of these. The first two were just a little bit of foiling practice to get you used to that. All right, y'all, next we'll get a start on 4.8. So 4.8 is applications of polynomials. And when you see applications, that means word problems, okay? Um, but we're not going to start out with the two word problems. Let me zoom in a little bit and get this where y'all can see it. So y'all, I got a graph here. They want me to use this graph to find the x-intercepts and the solutions. But you remember a while ago when we were doing the zero stuff, I said x-intercepts are the same as the solutions. So when they want the x-intercepts, they want this point and that point. Well, y'all, this point right here, let's see, -1, -2, that's at -3. So the first x-intercept would be -3, 0. So x-intercepts have to look like an ordered pair. And then y'all would put a comma and then write the next ordered pair. Well, y'all, that one's over here at 1, 2, 3, 4, 5. So that ordered pair would be 5, 0. X-intercepts always have a y value of 0 because they're on that line. Remember, the y's go 1, 2, 3 up, -1, 2, 3 down. Anything on that line has a y value of 0. Now, it wants the solutions. Well, the solutions are actually the numbers where it crosses the line. That'd be a -3. And then that crosses at 5. So if you was to solve this by factoring, quadratic formula, any method, you would get them two answers. So y'all, same thing here, right? They're looking for the x-intercepts. Well, this x-intercept is at what, -2? So that was going to be -2, 0. And then comma, the next ordered pair is over here at 2, 3, 4. That one's at 5, so that one would be 5, 0. You know, and they're just keeping you squared away on the difference between x-intercepts and solutions, okay? All right, so we know the solutions are going to be what? The -2 and the 5, which is equal to the x values of those x-intercepts. All right, y'all, so we'll wait on this number 3 till we come back from break. So let me stop my share here. And share my screen. All right, so the first two, we're just looking at the graph that I showed you. So for number 3, they say a wire is stretched from the ground to the top of an antenna tower. The wire is 10 feet long. All right, then they say the height of the tower is 2 feet greater than the distance D from the tower's base to the end of the wire. Then they say find the distance D and the height of the tower. All righty, so the last two are word problems. So a wire is stretched from the ground to the top of an antenna tower. So I'm just going to draw some kind of antenna tower here. So y'all, there's my tower. Now I got a wire being stretched from the ground to the top of this antenna tower. So I got a wire stretched from the ground. So this will be my wire. And it says the wire here is 10 feet long. So this is 10 feet. So now they're saying, hey, the height of this tower is 2 feet greater than the distance D from the tower's base to the end of the wire. So this is the tower's base, and here's the end of the wire. So this, they said, was distance D. And then over here, the height of my tower, they said, was 2 feet greater than this distance D. So this would be D plus 2. Okay, so you have your distance D, your wire, and then the height of your tower will be the D plus 2, okay? They want you to realize that this makes a right triangle with a 90-degree angle here. And we got a formula that'll solve a right triangle. So y'all, the formula I'm going to use to solve this triangle is called the Pythagorean theorem. That says a squared plus b squared equals c squared. And the c always has to be the hypotenuse. So the hypotenuse is the longest side of the triangle that's opposite the 90-degree angle. So this wire is the longest side. So that has to be C no matter what. And then I'll let this be A and B. All right, so my A squared will be D. So that's going to give me D squared. B was D plus 2. So that's going to be D plus 2 squared. That's going to equal c squared, which will be the 10 squared. So d squared plus d plus 2 squared equals 10 squared. So you just plug in for your A, B, and C in the formula. All right, at the moment, I can't do nothing with the d squared, so I'm bringing that down. But y'all, I need to do some side work over here. Because remember, I got a d plus 2 squared. And remember, support homework told us if we got a d plus 2 squared like this, we need to write that twice and FOIL it. So that's what that support was for, so you remember how to FOIL this stuff, okay? So I got d times d is d squared. D times 2 is 2d. 2 times d is 2d. And then 2 times 2 is 4. All right, then you want to add like terms. So you get a d squared. 2 plus 2 is 4d. And then plus my 4. So y'all were asking on the test if you had to draw the picture out? No. All you got to do is on MathLab put them answers in and be done with it, okay? I don't think this is one where I make you show work on. All right, y'all. So this d squared plus 4d plus 4 is now going to replace the d plus 2 squared over here. So that'll give me d squared plus 4d plus 4. That's going to equal the other side, which was 10 squared. Well, y'all, 10 times 10 is 100. All right, so now we got to work on trying to solve this for the d's. First thing you notice, a d squared plus a d squared are like terms. So add them together, you get 2d squared plus 4d plus 4 equals 100. All right, so my next thing is, this is quadratic with the d squared term in it. So what we need to do is make this a 0 over here. So to make that a 0, you're going to subtract 100 from both sides. Because remember, for a quadratic equation, you need everything on one side equal to 0 on those, okay? So you always get a 2d squared plus 4d minus 96 equals 0. Now, I'm going to do one more thing, and y'all are going to be able to do this also. All of these numbers here, all 4 of these numbers will divide by 2. So since I got a 2 in front of my d squared, I'm going to divide everybody by 2 now. Because dividing by 2 will make my numbers a lot smaller. And you can do dividing as long as everybody divides by that number, okay? So that'll give me 1d squared plus 2d minus 48 equals 0. All right, so now we're down to the part where we're going to solve this by factoring. Now, if you want to, you can do the quadratic formula, or y'all could even graph this to get the 2 answers. I'm just going to factor it real quick. So the d squared is a d and a d. Y'all look here. This last number is negative. So anytime y'all's last number is negative like this, you're going to get unlike signs for your factors. All right, so let me write the factors of 48. 1 and 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Since this last number is negative, I need two factors that'll subtract and get that 2. And y'all, that's going to be 8 and 6. Now remember, when you got your two factors, the larger factor, which is 8, will have the same sign as the middle number, which is a positive. So you need to make the 8 positive and the 6 negative. 8 minus 6 equals 2. 8 times negative 6 equals negative 48. All right, so once you got it factored, but y'all remember, let me show you how to, if you don't like factoring, let me show you how you can get these two answers. So let me finish this out real quick by setting both of these equal to 0. So y'all, the first one, I would subtract 8. I get D is a negative 8. The second one, I would add 6 and get D equals a positive 6. But y'all remember, if you don't like factoring and you don't like plugging stuff into the quadratic formula, let me show you something real quick. You can graph this equation, and you can graph it at this point where I got the 2, or you could graph this one where I got the D squared. It don't matter. I'm going to go and I'm going to graph it when I had the 2D squared plus 4D minus 96, okay? So let me clear this off. I'm going to go y equals, and I'm just going to do the 2. Now remember, instead of D, you got to use x's on here. So 2x squared plus 4x minus 96. So I'm just going to graph it before I even divide it by 2 to make it smaller. But y'all watch this graph. You remember my two answers? Look here. -1, -2, -3, -4, -5, -6, -7. That's crossing at -8, which was one of my answers. In the right side, 1, 2, 3, 4, 5, 6. That was my second answer. And then remember, if you look on the table, well, right there at 6, you got a 0 for the y, and then go up here to that -8. At -8, you got a 0. So graphing is one way to find those answers if you can't factor, okay? Now, only one of these answers I'm going to keep. I'm looking for the distance of D here. Well, D can't be a -8. So when you're looking for a problem like this and you're looking for distance, y'all see this -8? You got to cancel that answer out. You can only keep positive answers. So that means that this D is 6 feet. Well, if this is 6 feet, the height of the tower was D plus 2. Well, if D is 6, 6 plus 2 makes this side 8. So once you got your D, you add 2 to get your tower, okay? So for that one, your distance D would equal 6, and then your tower would equal to 8. And this here is what MATLAB will want. Okay. All right, y'all, but I just want y'all to realize at this point, I solved it by factoring. But remember, at this point, when you had this all equal to 0, you could have factored, you could have got the answers by doing the graphing, okay? All right, y'all, so you gotta love word problems. So here's number 4, and it's another word problem. The foot of an extension ladder is 7 feet from a wall. The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. They want to know how long is the ladder. Hey, so y'all another triangle problem coming up. So I got a wall over here. And there's a wall, there's a ladder leaning on it, and they're telling me the foot of the ladder down here. So let me draw this ladder real quick. They're telling me that the foot of this ladder right here is 7 feet from the wall. So this distance right here is 7 feet. Then they say the height it reaches on the wall, which is over here, the height it reaches on this wall and the length of this ladder are consecutive integers. So consecutive integers is two numbers that are in a row. Like consecutive integers would be 1, 2, 3, 4, 4, 5, 5, 6, 7, 8. Those are consecutive integers, 9, 10. So how do you go from one integer to the next? Well, y'all, if I let this height right here that it reaches on the wall, if I let that be x, then to go from x to the next consecutive integer, you would take that x and add 1. So that's what it means when they say consecutive integers. Here's a number, here's that number plus 1. That's how you go from one integer to the next. So if this was 0, 0 plus 1 is 1. If this was 2, 2 plus 1 is 3. See how this is 2, 3, 4, 5, 6, 7. That's what they mean by consecutive integers. Now, this is also a right triangle because I got a 90-degree angle here. So I'm going to use a squared plus b squared equals c squared. So I know c has to be this longest side over here, opposite the right angle. So y'all, I'll let this be a, and that be my b. So let me fill in for a, that was 7. So I'm going to have 7 squared plus b, which was x squared, is going to equal c squared, which is the x plus 1 squared. All right, y'all, so let's simplify stuff. 7 times 7 is 49. Can't do nothing with the x squared for the moment. Uh-oh, y'all, side work. So on the side, I'm going to figure out what x plus 1 squared equals. So x plus 1 squared means we got x plus 1 times x plus 1. So we got to FOIL this one again. Okay. So y'all, x times x is x squared. X times 1 is 1x. Then we distribute the 1. 1 times x is 1x. 1 times 1 is 1. I want to add the like terms, so bring down the x squared. 1 plus 1 gives me 2x, and then bring down my 1. So the right side of this is now x squared plus 2x plus 1. Now, y'all, let me tell y'all something. When y'all are doing this problem, the only difference for y'all's problem and mine is going to be that 7. So you'll get a different number where I got to 49. But y'all, everything else on y'all's problem is going to match up with mine. You're going to get an x squared, and then you're going to have an x plus 1 squared. At this point, the only difference between my problem and yours will be whatever number y'all got right there. Y'all might have a 4, 9, 16, 25. You'll have some kind of perfect square sitting right there, okay? So this one's quadratic, it looks like. So I need to get all this stuff over here. So let me start out by subtracting that x squared. So since I want to move this x squared over and it's positive, I subtract x squared from both sides. So y'all, the left side, all that's left is the 49. But y'all look at this. These x squareds right here canceled out. Well, these x squareds also cancel out. So that all that's left is a 2x plus 1. Y'all's x squareds are going to cancel out just like mine did. At this point right here, y'all, the only difference between y'all's problem and mine will be that 49. Unless y'all's ladder was 7 feet, then it'd be exactly like mine, okay? But y'all are going to have a 2x plus 1 on this side, just like I did, okay? So would y'all look at this? This is not quadratic no more. This is not quadratic because I don't have those x squared terms left in it. So since this is not quadratic, we're just going to solve it for the 1x. So to solve that for the x, I'm going to subtract 1 from both sides. So 49 minus 1 is 48. That's going to equal my 2x. And y'all solving that for x, I divide both sides by 2. So 48 divided by 2 gives me 24. 2 divided by 2 makes that a 1x. So look here, x is 24. X is this height on the wall. But y'all, they didn't ask me for how high on the wall was the ladder. They want to know how long is the ladder. Well, the ladder was x plus 1. So if x is 24, 24 plus 1 makes that ladder 25. So the length of the ladder equals 25. Now, what kills people, they forget to add that 1 and they put in 24. Well, y'all, 24 ain't the height of the ladder, okay? You physically got to come back and add that 1 and get that 25. All right, y'all. So I will say this. I'm not going to get into this today, but tomorrow we're going to get into what we call the vertex formula. So 7-5, and it's not real long, and then we're going to knock out 6-1 and 6-8. So 6-1 is really short, and then 6-8 ain't really that bad either. So we'll knock out them tomorrow, and then Monday we'll finish the test 2 material, okay? I wanted to sort of keep it mellow today, doing this 7-4 and 4-8 for you. Okay, so, and then that way y'all can still focus on that test y'all got, okay? So do y'all have questions on this today?
I don't have any questions.
All righty, so y'all are good.
Yes, sir. All good.
All righty, so y'all give me about hour or so and I'll get this video uploaded to you in your email. That way y'all got it to look back over if you need to. And y'all, I'm gonna stop this recording.